As promised, we took a look at block size 16 and looked at how the network IDs worked out with there. But what if it's not a block size 16? What if we have a different block size? What do the numbers look like? How do we engineer that? Let's take a look at a block size 32 and maybe a block size 64 and get an idea of what those numbers look like. So remembering that we use our little formula of 256 minus funky is block size, we took a look at /28 previously, which is 240 as a subnet mask, which gave me my block size 16. So what if we use a different mask? If you think about the different values that we had, the possible values that we could have for subnet mask were 240, and this is kind of starting in the middle, kind of a funky place to start, but 240, 224, 192, 128, 0, 248, 252, 254, and then 255. And the funky values that we use, those funky values, were the 254 down to 128. And realistically, what you work with most of the time are only 252, maybe down to 192. So of all the possible subnet mask values that you can have, these are it. There aren't any more. So really, when you get right down to it, I mean, how many different block sizes are there? If this was my block size 16, I only have 1, 2, 3, 4 other real blocks that we look at. Again, you may see an occasional 128 or a 254, but that would be in the third octet, not the fourth octet typically, just based on the values that we would use. The more common values and things that you'd probably see in the real world, if you even get to this variable length subnet masking or this non-octet boundary masking, is going to be in this block size range here. If you did need to carry it out to 128 and 254 at some point, you'll find it work exactly the same. So we'll kind of focus on a few of these here. If I wanted to go to maybe my next increment, a block size 16, so maybe what I should take a look at is an IP address that would use a block size 32. Again, the next one would be 32. So 200.200.5.100/27. In a previous example, we had used /28, which was my block size 16, so now 27. So now what do I do? Well, I have to see where /27 is. What is that? And if I do out all the numbers, all the ones, I find out that in the fourth octet, /27 makes it look something like that, which converted to decimal is 224. So what's my block size for 224? It's 256 minus 224. That gives me a block size of 32. Well, how do I do that? Oh, so now I have to do 0 plus 32, plus 32, plus 32, plus 32. No, we don't have to do that. It turns out that every increment of 32 is also in this block size 16 column. So if I have my block size 16 column, so this is 0, 16, 32, this is just adding 16 every time, I can do the same thing. I can do 0 plus 32 is 32, plus 32 is 64, plus 32 is 96. But if you look at the block size 16 column, these values are just every other one. So 0, skip 16, 32, skip 48, 64, skip 80, 96, skip 112, 128. Now I'm not doing math anymore. Skip 144, 160. Skip 176, 192. Skip 208, 224. Skip 2, that's it. And there should be 8 values in here, and there are. So this is our block size 32 column. So like we did with 16 before, we found out where in the column an address lives, and that gives us an idea of the network ID, and the broadcast ID is one less than the next network. So can we do this? Will this work for us? This is that 200.200.5.100/27. So where is /27 in my block size 32 column? I'm sorry, not /27. Where is 100 in my block size 32 column? Well, 100 is right there between 96 and 128, which makes 100 on the 96 network. So what's the broadcast address for the 96 network? It's 127, one less than the next network ID. So the valid range of addresses of all the devices that are in the same broadcast domain as 100 are 97 through 126. If the IP address of a device you're looking at is 200.200.5.97 through 126, it's going to be on the same network as 100, and we're going to broadcast for the MAC address locally. If the address I'm looking for is outside the range of 97 through 126, It's not on the same network as me. I'm going to broadcast from my default gateway, and I'm going to send it to the router instead. That would be a block size 32. Now, this was the same number that we used in a previous example. Same network, but the broadcast address was different. When this was a block size of 16, my broadcast address for 96 was 111. Now that I'm using a block size of 32, it's a broadcast of 127. Wow, that's like twice as many addresses. Yes, that's exactly right. It's twice as many addresses. 16 and 16 is 32. It gives me a bigger block. That's why we would pick a /27 over a /28, is because we had some requirement that we needed more than 16, more than 14 addresses. And a lot of times when we pick a subnet mask, when we're going to use one of these funky masks, what we're doing is we're picking it based on the number of hosts that I need. If you told me that I had a network that required 20 hosts, and I wanted to come up with the most efficient subnet mask I could, what I would decide was what block size will give me 20 host addresses. So can I use a block size of 16? Do you think you can use 20 different addresses if you only have 14 available? No, 14, it says 16. Remember another thing, 2 to the n minus 2. This is the number of bits that we have, or block size minus 2. Remember, on a block size 16, I can't use, if it was 96, I can't use 96 because that's the network ID. I also can't use 111. So out of the 16 addresses in the block, there's only 14 usable. I have to always subtract 2. On my block size 32, it's the same thing. I've got a block size 32. I can't use 96. I can't use 27. So how many addresses do I have? Well, from 97 to 126 is 30. I had to subtract 2. Can I fit 20 hosts in 30 addresses? Sure, I absolutely can fit them there. So I would pick a block size of 32 for my 20 hosts. That dictates what my subnet mask is. If I need 30 hosts, if I need between 14 and 30, I'm going to pick a /27 because that gives me the number of hosts that I need. Oh, we don't need 32 hosts, we don't need 30 hosts. I said 20 hosts? I'm sorry, what an idiot. That was supposed to be an 8, that's 80 hosts. I need 80 hosts. Well, now I got a problem because I can't fit 80 hosts in my block size 32. What do I need? I need a block size 64, or I need a block size 128. Can I do that? I can do a 128. Maybe I should have picked a different number to do this example. Why not? We'll leave it where it is. I'm actually going to save this I'm going to save this one for later. Let me erase this for now. I'll put it up here because I don't want to just leave it out. I don't want you to think it's not something we can do. So I'll put this 80 hosts down here and come back to it. But let me give you a different example to start with. What if I said 50 hosts? Now what block size do I need? Well, again, my block sizes are 16, 32. What would be the next one? The next block size would be, well, would be double 32, which would be 64. Oh, if you actually look at my binary progressions here, these are my block sizes right here. So if I wanted to, I could actually go up here and say that my block size 16 was my /27, 28. Let me make that a little clearer where I just wrote over that on you. My 16 was a block. So you know what I'm not going to do is I'm not going to put the slash number in here. This is 28. 32 was a /27. What do you think? You see a pattern here? You think 64 might be a block size, it might be a /26? You think a 128 might be a /25? An 8 would be a /29? A 4 would be a /30? And we can't really use 1 and 2 here. It's in the 4th octet, so we won't do 31 and 32. And again, in the real world today, we can make exceptions to the rules. Cisco has written exceptions to their iOS that will let you, in some cases, put a /31. In some cases, we actually see /32 when we define all the bits. But as far as classical subnetting, which would be probably more what you're interested in, I'm not going to use /31 and /32. These will be the only ones that I use. So to get a block size 64, I'm going to use a /26. Oh boy, so what is /26? I don't have a block size 64 chart over here. What am I going to do? Hey, we remember how we generated it last time? What I did was I looked at my block size 16 column and I just went every other one. Do you think 64 might do the same thing? It does. Everything in the 16 column, everything in the 32 column is also in the block size 64. So 0 plus 64 is 64, and you can add 64 and get to 128, and add 128 and get to 192 if you want to, or you can just look at every other one in this column. 0, skip 32, 64, skip 96, 128, skip 160, 192. Again, your choice how you set this up. But with your block size pieces put out there, it makes it very easy for me to see. Let me go back to the example that we used in the past, this 200.200.5.27. Let me do this now as 200.200.5.100. You gonna guess? /26. What is 26? You should have been telling yourselves immediately, it's block size 64. If it's a block size 64, where is 100? It's right there after 64, so this is on the 64 network. What's the broadcast address for 64? 128, so it's 127, one less than the next network ID. What are the valid range of addresses? 65 through 126. There you go. So any device that has an IP address of 200.200.565 through 200.200.5.126 is on the same IP subnet as this guy, and we will ARP locally. If it's outside this range, I don't care if it's still 200.200.5, if it's outside the range of 65 to 126, then I'm going to ARP for the default gateway, whatever its IP address is, as defined by your infrastructure, and that's where I'm going to send the packet. The router will know what to do with it. That's block size 64. Now, earlier, I kind of went ahead of myself and gave you the number 80 and said, what if I have 80 hosts? What if I did have 80 hosts? What block size would I need? Well, you know what? 80 won't fit in 64, but 80 will fit in 128, and that would be a /25. How does that work? Well, I could do the same thing over here, 0, 64, 128, so 0 plus 128 is 128. Well, it's only two. There's only two addresses, only two blocks. So where's 100? 100 is in the 0 block, so it's on the 0 subnet. What's the broadcast for 0 subnet? 127. What's my valid range of addresses? 1 through 126. So it works exactly the same way. Don't let it throw you off. Easy subnetting.